So, hello together also from my side. I have the honor to commit the next presentation to you. Now we've actually heard how to bring the physical world into the virtual experience, and my presentation will gonna be on how to actually bring a virtual experience back into physical reality. Speaking of 3D printing, especially of 3D printing formworks and facades. I want to start quickly with a short introduction of the company and the technology, how it might differentiate from other 3D printing technologies out there, and then we look into some applications and success stories. voxjet is a company founded in 1999, actually here in Munich. Back then we focused on binder jetting, or since then we focus on binder jetting, grew over the times, went public in 2013 on the New York Stock Exchange, and since then grew our network with 4 global locations, more sales partners, and by now quite a lot of different or big printing volumes, up to 400,000 liters per month. So our process in 3D printing is binder jetting. How does that work? Actually, you have your CAD file, you put that on the machine, and then the machine actually slices your CAD into tiny layers of pieces. So, and then the printer starts by laying down one layer of particle material, followed by the print head, in that case, that applies a binder. In essence, it's a glue just on those spots where you actually want the material to be melted or glued together. Then you lower the build platform and you start that process over again until you've reached the height of your desired part. Then you actually unload this, we call it job box, full of bonded and unbonded material, and you remove the unbonded material by just sucking it out by vacuum cleaners, in essence. Then you use compressed air to remove powder adhesions, etc., and then you have your final part to continue to the next production step. Our business model is, in essence, based on 2 columns. On the one hand side, we have the service business, which is actually, we're a copy shop. You send us your CAD files, we print them for you, flexible, which means you have them in days to and weeks, not months. And on the other hand, we have the system side of the business, where we actually develop these printers and sell them worldwide. And both these columns go hand in hand, meaning if you're new to the technology, you don't have any experience, you want to try it out, you have a low barrier, just use the on-demand production to do some trials. Then if it works out, you increase the volumes over time and until the point where it's actually more economically for you to run an own printer, and then you might even have overcapacities where you can use our service center again. Now, I've talked a lot about 3D printing and 3D printing processes, but let's say some of you just might know 3D printing from going to the next electronics store and seeing this small box here that's called 3D printer. Yes, it's also a 3D printer, but in our case, it's rather something big. A build platform 4 meters by 2 meters by up to 1 meter in height. And of course, well, that's industrial equipment, which also reflects in the price. Our applications, or where is this technology actually being used? We come from metal casting, so we actually print sand molds or PMMA patterns for sand casting, or investment casting for automotive, aerospace, heavy industry. We also print plastics for architectural models, designs. So here, for example, you see a designer lamp, but also functional, rigid parts. Or we use it for tooling, where we also categorize concrete into, where it's basically using the sand molds we know from concrete or from sand, metal casting, using that to pour concrete. So it's actually formwork that we're printing, or other tooling such as carbon fiber lamination or vacuum forming. 3D printing in construction or concrete printing, in essence, is already out there for a few years. Most of you might know these kind of 3D printers that can print entire houses based on extrusion. Then there's another variation of that where you have a robotic arm and a matrix attached to that to realize such nice complex columns. And where we come in is actually a third kind of technology, as just said, the binder jetting. So we don't print concrete directly as the others do, but of course, each technology comes with its benefits and disadvantages, such as binder jetting is good for accuracy, geometric freedom, fine detail resolution, while the others might realize bigger build volumes or be faster by volume. But why do we think the approach of printing formwork is actually a good one for the construction industry? And this is when we look at the cost distribution on a construction site. And when we look at this, you see that almost 50% of the cost is distributed to formwork. And a lot of that, or let's say, the more complex your geometry gets, the more expensive gets the formwork. And this is where 3D printing comes in. So if you look at this, 3D printing is not price efficient or price effective if you just want to realize plane areas, rectangular, or even singular curved parts. Where it really brings an additional benefit is when you have a high complexity, so which means multi-dimensionally curved geometries or even surface structures on top of that you might not be able to realize with conventional methods anyway. And then you have, of course, two ways of application, which means on the one hand, you can realize complex formworks that are reusable, or you can just produce one-offs, which means you have a very complex shape, but you have to actually destroy the mold to demold your concrete pad. Where have we used these applications so far? So, of course, formwork, but formwork is quite a broad area. So we have functional walls or ceilings where we actually integrated electric connection, fires, fire installations, etc., in the printed part already. So you didn't have an additional step once you have casted the concrete that you have to actually hammer the line out, put the electrics in, and then save that step. Complex facades, of course, or if it comes to customization, individualization with logos, lettering, or also in the art and design section where you then have sculptures, furniture, so highly individualized stuff. Looking at this, for example, we had to renovate the facade here, so the upper part and the two columns here, which was done in a way, so first of all, we have to work with CAD files. How do you generate a CAD file? You actually use 3D scanning to get to these CAD files, and then we actually printed the geometry, or after having them repaired virtually, printed that out in several pieces, so you can see the parting lines here. And in that case, it was not used to cast concrete, but to actually work as a draft for sculptors to sculpt it out in stone. But just to give you an idea of the sheer size of that project, this is just one part of the column being printed in two individual pieces, and these were then sent around the world to various sculptors to work simultaneously to save time and bring that facade back to life. Another concept study comes from the university in Lund in Denmark. This is actually a wall printed out of sand, And as just mentioned before, this has already various kind of installations included, such as air filtration, a ventilation system, rainwater runoffs, but also habitats for nature and so on. Of course, that's very futuristic as it is a concept, but this is something where also the technologies could head to. And then, let's say, starting with concrete casting itself, we also started very small on a lab scale. So we printed this sculpture here by printing the formwork. So you actually just take an offset of the part you want to print. You actually give it a solid base, so you can pour the concrete. And then the speciality with this, and also this is where 3D printing has another advantage, is the mold division. So you don't have to actually divide the mold in half straight away, but the departing lines of this mold were put behind the ears where they are not visible when you look at the sculpture itself. After the lab tests, of course, we also went bigger. Some of you might know this project. It's Stuttgart 21, a famous train station that's currently being built in Stuttgart. And out of this column, we took out a small piece and did a prototype. So up here you see the red parts. These were actually 3D printed, joined with conventional formwork, and then actually cast in concrete. So the printed molds or formwork are handled the same way as conventional patterns. And in that case, we were quite lucky, so it worked. Apparently, as you see, it's still quite thick, the printed formwork itself, so and therefore heavy. But it was water repellent. It doesn't soak. It doesn't, become bigger over time and soak the water. But of course, there was room for improvement. And in the next step, we actually did another project together with formwork company Doka, which is a staircase with a multi-curved, a multi-curved formwork, which you can see here. So in that case, we really tried to max it out. So we printed the formwork elements just 21 millimeters thick to perfectly being joined with a conventional wooden formwork. And then it was attached to a standard cleat box to come together to the final formwork. Also being seen here, so everything that's black was actually 3D printed. And even up here, the conventional way had to be readjusted to perfectly fit with the 3D printed part, but overall it was a perfect fit. And also on the construction, we had just deviations of less than a millimeter when joining it with the total formwork, and also, well, the casting came out great. Another project is columns. So you see these is a project in a village close to Munich, where they actually had these columns to be casted, and they had these complex Roman capitals to be realized. And here we also printed these formworks, divided them in two parts, integrated joints already to perfectly fit together. Then another project in Switzerland. Again, here we work with prefabricated molds, so no casting on the construction site itself. The formwork is made up of several individual pieces, then post-process in a way that you have a smooth surface and a sealed surface, so the water out of the concrete can't actually penetrate into the printed formwork. Then a fiber-reinforced shot concrete was applied, and then 10 of these individual elements were assembled on the construction site, working as a functional ceiling that already had technical installation like light and fire sprinklers included. So the approach in essence is, of course, you can also realize greater areas by using 3D printed formwork. However, of course, if it's just a standard or let's say not that complex geometry, it is not that economical. So let's assume the case you have a huge facade, several hundreds of square meters, and you want to realize that with a complex geometry. You would usually do that in a way that you take out, let's say, 5 individual pieces, like a puzzle that can be puzzled together again, and that are repetitive. We would then print these formworks and take off a silicon mold of that, which has the benefit you can reuse the silicon mold more often than a printed sand mold. And once your silicon mold has reached the end of life, you still have your master mold 3D printed to take off another silicon mold of that. And that way, there's a project currently realized, you can actually, really realize a lot of square meters using or making use of this technology. For example, with, let's say, you have surface geometries like a bar clock, for example. So how does such a silicon mold look like then? On the bottom, we have a small example. We actually had the 3D printed part with a complex surface structure, took off that silicon mold of that, so we have the negative, and then used this one to cast concrete again. But that way, as said, you can realize all kinds of geometries. So you have the waveform here, then half bulbs on top of that, and then included lettering. That would be just an example that you can't realize with conventional formwork. Another example that's basically a prototype or a concept study is columns. So that way the designers or architects actually produced one column in 3D printing with sand, paintbrush that to actually see whether it fits the construction site and whether it, as a proof of concept, whether it can be realized the same way. Or restoration, again, you scan the facade, you print the mold and pour concrete into it to get it back to life. And then last but not least, it's actually, let's say, we call it our company stone, where you have the company logo, but that is something like a rock formation where it's integrated into and it has undercuts, etc. So the mold that you can see on the top here cannot be demolded without being destroyed. And this one was then integrated into a standard wooden formwork. So we just used wooden boards to cast the outer sides of that stone. And then on the next slide, you actually see the undercuts that were realized. So you have smaller diameters or smaller wall thicknesses here. Then at the front, you have functional integrations like holes that water from raining can just flow through, and ice, for example, doesn't get stuck and break the concrete part. So why should you use 3D formwork for your project? First of all, of course, I want you to take 3 key aspects away. One is efficiency. So, of course, you have a fully digital planning or assembly line. So you plan digitally, you produce the mold or the formwork digitally, and then you integrate it into or on the construction side, which saves you time on the planning side. And especially if you follow that hybrid approach, you also have an economical effort. So don't print the full formwork and the full area using 3D printing, but just take out the bits and pieces that are really complex, multidimensionally curved, etc. Then flexibility, as just said, still a digital data chain. So if you actually have to change something on short notice, that can be easily realized by just pushing the button, and the printer will print the part again in the changed design. It's scalable, which means, well, we run printers from sizes like a shoebox up to 8 cubic meters, 4 by 2 by 1 meter. And even if that is not enough, you can still slice your design into several pieces and puzzle it back together. Functional integration, as I mentioned, fire sprinklers, etc. And you can either use the printed part directly to pour concrete or use it as a master mold to actually go the additional step, taking a silicon mold of it, and then use the silicon mold to cast the concrete. Ready to use, which means, unlike other of the 3D printing technologies I introduced you today, this is already a technology that's being used on construction sites there today. It's been proved that it's reliable and reusable, and well, it's also approved to being able to withstand all kind of casting pressures that you actually might have or that are needed by just formwork constructions. So I'm a bit ahead of time, but that will already be the end of my presentation. If you have any questions, feel free to come up or visit us at our booth to actually look at some 3D printed formwork or also cast parts. We're in hall B3 at booth 342. So yeah, feel free, and thanks for your attention.